This is a network with a set of users. This network is managed by our network administrator. It also has a host of applications being run by the users, like business and productivity tools, web-based searches, as well as social networking applications. Here we have hardworking Harry, who is running his everyday business tools. Harry is finding network issues while running his applications. So he calls up IT for a solution. But IT responds by saying that they will have to look into the issue, and it may take some time. On the other hand, we have lazy Larry. He might not update his manager with the status, but he never forgets to update his Facebook status. Larry realizes the potential bandwidth his company has to offer. So he puts it to the best use that he can think of. He starts downloading using illegal means and downloads music, movies and games. This leaves our network administrator deflated, as he has done all that he could, but still can't solve the inconsistencies in the network. He desperately needs a solution. It's AVC. Application Visibility and Control, or simply, AVC, provides an insight into the top N application statistics, which provides classification information and effective network monitoring. It allows management of business-critical applications, for better network utilization and allows policy per application on network elements. Amongst AVC solutions, Domain Name Systems, or DNS, is a lightweight application recognition engine, based on DNS domains. While Deep Packet Inspection, via NBR2, is a heavyweight application recognition system, based on inspection of Layer 4 to Layer 7 headers. Using AVC on the network devices, our network manager can gain application visibility in the network. Further, AVC can be clubbed with QoS, or PFR to control application network usage and improve application performance. However, AVC comes with its set of problems. It can decrease network throughput. Mobility of users also poses a big challenge. And variation in topology also makes it difficult to monitor and manage devices on the network. With all these issues, our network administrator has nowhere to go. And so, the network gods open their gates, and send forth SDN. Our solution is to combine AVC with identity services, and deploy it on an SDN controller. With the SDN controller, we can manage the topology, users, statistics and other elements of the network from a centralized controller. We can add our own AVC module to this controller, and use 1PK, to communicate with the AVC service on the iOS service blades. Finally, we can have a business logic residing at the user end, and achieve communication with the controller, using REST APIs. Combining AVC and SDN via 1PK, provides opportunity to export existing services using 1PK, and program the rest of the devices using OpenFlow via the controller. Sell licensed iOS software on service blades. Chain existing services, enable Cisco devices to be even more relevant in an SDN-based network. And finally, SDN plus AVC plus Identity, provides an application-based network segmentation, for better network management. And, a complete visibility into the network, users and their applications, for a per-user application policy. All in all, our solution brings happiness to a lot, sadness to a few, and is the perfect tool our network manager was looking for.
The packets from a host are L2 forwarded to the service blade, which classifies them using NBAR. The classification and 5-tuple data is exported by the service blade to the controller using 1P APIs. The controller then programs the network elements based on the required business logic. Let's take a look at a demo. Here, we see that a host is accessing a video which the administrator can block or unblock using the application. The app gets the top 10 applications from the controller and applies a policy to block an app. Host is connected to a media server. Host sends DNS query and gets a DNS response. This is cached in Software Router. ODL controller gets the mapping using 1PK APIs from Software Router and applies the policy on the network. We can see the stream running. Now we apply the policy to block the stream. We have Java application which register the domain and policy using REST APIs to ODL controller. Policy is applied. Video gets stopped. Now we unregister the policy. We can see video continues. Thank you.